Howdy, Earth Science folks. Good to see you again. Good to be seen. Today's target question. That was a tricky one, right? Who knew? Who knew such a beautiful tropical garden could exist so far north of the equator? We're going to talk about why today, but the short and sweet, ocean currents. Ocean currents can travel great distances and take energy thousands of miles in warm locations up. So we're going to look at real fast the target question here. It's you had something, a picture that looked like this, right? And it's potentially deceiving, right? Like you look at it, you see a big old palm tree right in the middle of it. And it's hard to argue that that looks like a tropical location. And it is. It just happens to be very, very far north, which is unusual. So here's the actual location. Islay, Scotland. All right. I probably said that wrong. I apologize. But it's really, really far north. It's farther north than all of the upper peninsula of Michigan. Yet it has a warmer average temperature. That's a little weird. Why does it do that? It's because of this ocean current right here. Most of us, not everybody, but a lot of us have heard of the Gulf Stream, right? So if you look right here, this is North America over here. It's kind of hard to tell. We got like Maine and Northeast there, right? This is the Gulf of Mexico. No, this is the Gulf Stream, which is a really, really, really warm ocean current. It's warm water that warmed near the equator. And here's what happens is it shoots across the Atlantic Ocean, right? Well, here's Europe, okay? This warm ocean current, this warm ocean water sits right here to the west of Europe. And then because we live in the westerlies, the air from the ocean gets pushed, that warm air gets pushed over Europe. And as a result, they have a much higher average temperature than they should for their latitude. So what I want to do is I want to go back to our notes that we've been working on, and we're going to take another final look at this and look at the graphs for one last time here. So we've been working on these climate, not climate notes, right? And we're going to look at factor number 5 today, ocean currents, okay, and how they affect the climate of two different locations. So we're going to look at Detroit, which is roughly 45 degrees north, and London, which is roughly 55 degrees north. I rounded, but you get the idea. Pretty close. Okay. So far, you guys, we've done the front side, right? We did the Life is a Beach, and we've done 3 and we've done 4. So now we're going to take a look at number 5, and I'm not going to spend as much time as I normally do going over the precise details of where things begin and end. I'm going to show you what the climate graphs look like and then explain them to you. So here is my beautiful creation. Sorry about the moving blah, 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 blah. But anyways, let's go ahead and look at this together. So Detroit. We've done the Detroit climate graph a few times, all right? But you can see from winter to summer, back to winter, we got a good seasonal change, right? No shock there, right? We know how the seasons can change here in Michigan. So we have a pretty sizable change in our season. So the range is bigger. And that's because Michigan is a continental climate. We live in the middle of North America, right? So we get air from the land. Our average is right here in the middle. Compared to London, it's lower, all right? And that's surprising because most of the time we think, okay, 55 degrees north, that's really far north. Here in North America, that's way up in Canada, as they say, right? So why is it warm? Right? It has a much, much, much higher average temperature. And again, it's that warm ocean current. Remember, the sun heats the earth heats the air. So if you have a warm body of water, that warm water will warm the air. And that warm air gets pushed over Europe because of the wind belts. Europe is much warmer than it should be for its latitude. Okay. So it has a higher average temperature. Now, fun fact. I'm going to turn this off. It's not really all that fun. Europe will not continue this forever, right? Right now, if you look up here in the North Atlantic, we got this big chunk of ice, the Arctic ice. That Arctic ice is melting. And an interesting thing about freshwater is even though that freshwater is super, super, super cold, it's still less dense than warm saltwater. So that cold freshwater is beginning to cut off the warm ocean current from warming Europe. It's beginning to float on top of that warm ocean water, and it's beginning to cut it off. So in the long term, as the Earth warms up, Europe's actually going to get colder. Right. And that's an important thing to remember when we get to climate change. Not every location on Earth is getting warmer because of climate change. There are places that are getting colder. On average, though, the entire Earth's temperature is going up. All righty, folks. We'll talk about the why later. I'm going to get back to this. Thank you for listening. Thank you for being here. Thanks for laughing at my jokes in my head because I can't actually hear you. I can't. I want to, but I can't.